Welcome back to the Fierce Fish First Tech Challenge programming tutorial series. Our goal in this series is to provide simple and straightforward guidance in programming an FTC robot. And in today's video, we are going to be discussing distance sensors. So let's get started. Here I have initialized the drivetrain with the left and right drive motors and the IMU so that we can hold our target angle while driving. And we're going to see how we can apply the distance sensor to the drive forward method a bit later in the video. But right now, let's start out as we do all of the hardware by declaring it. So it's a distance sensor class that we're going to be using. That's the variable type. And I'm going to call mine front distance, because it is let's say it's a distance sensor that I've mounted on the front of my robot to get the distance from an object in front of it. So that's how you declare that. And then let's go down here and initialize it. We have to do it just like we did the IMU. We can't do it like we do the DC motors. So let's look at that now. It's front distance equals hardware map.get. And then this is going to be the distance sensor.class. And then the configuration name, which I'm calling front distance. Just like that. So let's review that. I went kind of fast there. This is the variable name that you're going to use in your code equals the hardware map.get. You need your class, which ours is distance sensor, and then the configuration name. So that's how you do that. So now the way we get the reading on a distance sensor is very much like how you get the position on an encoder, except we have to use a distance unit. So let's take a look at that now. The way we do it is the sensor name.get distance. And now we have to use a distance unit. So let's say I want to go centimeters. It's going to be distance unit because this is a class that we imported. It should import automatically if you press enter, just like I did. .cm, which in our case is centimeters. Of course, that's not the only distance unit. We have millimeters, we have meter, and then we also have inch. And then I'm pretty sure those are the only distance units, or at least the only ones I've ever used. But those are the distance units, basically. And that's how we get the distance on our sensor. So I'm going to comment that out so that it doesn't mess up the rest of the code. But now let's take a look at the drive forward method and see how we can apply that to this right here, our drive forward method. So now let's say we want to keep driving forward until we're a certain distance from an object. Now we're going to have to drive really slow for this to be effective, because the way the distance sensor works is it shoots a beam of light. It doesn't affect you. You can't really see this light, but it takes the reading of how long it takes to come back, and that's how it determines the distance it is from an object. So we got to drive somewhat slowly because it takes a little while to update. So now we're not doing encoder tick count, so we're going to replace this variable with target distance. And that's the variable I like to use, target distance, because we want to be that certain distance. So here, this all stays the same because you're just setting the power and declaring that you have two different powers there. But here, our condition, we don't need the encoder ticks anymore. We're going to back that out, and we're going to replace it with the distance sensor. So we're going to go front distance.get distance, and let's say we're going to go inches again. If that is greater than the target distance, because we want to be close up to an object. We want to be moving closer to an object. We don't want to be moving further away from that object. So that's how you would do that. And we got to move really somewhat slow. Yeah, remember, we got to move somewhat slow. And then this all stays the same as we reviewed in the IMU video. This is changing the powers accordingly to try to hold the angle. And then all that, the reset encoders. So that is how you apply it to the drive forward method. Now I mentioned in the Rev Blinken video that you can apply the sensors to this in a TeleOp space. So let's take a look at that now. So let's say this is let's say we're in TeleOp here, while op mode is active. We're going to be checking, like, let's say our front distance sensor, like if we're close up on an object that we want to change the color. So let's do it like this. If front distance, get distance, inch, inch, let's say that. And then if it is less than 2, let's say if we're within 2 inches of something, that we want to set the rev blink in color, and you would set the color or pattern, they're called patterns. If you want to learn about setting patterns, please refer to our previous video. It discusses how to set a pattern. Now I don't have the blinking initialized in here, so I can't show you that now. But then we're going to have to do the else statement and then set a different pattern. And that is how you can use LED lights on your robot to like make it more effective in aiding your drivers and not just like looking, not just there for looks. So, and I think that's going to be it for our video today. Today we learned about distance sensor and its applications in a drive forward method, as well as in the rev blink and LED class. So from all of us here at Fierce Fish, we hope you have a great day.